Okay, students. In this session, we will discuss we will discuss a new topic, but that topic will be related to the last topic that we have already done in the previous session. So we will be discussing here multiple DES. So if you remember, in the last session, we have completed one of the important topic in case of information security, that is DES. So DES was data encryption standard. But here in today's session, we will start with a new topic, that is a multiple DES. That is the continuation with that particular DES part. Okay, so in the last session, if you remember, we have discussed that DES portion, and we have seen that there are some features of the DES, that it contains that crystal round. It is a symmetric process, and we have a total like 16 rounds are there. And after the completion of the 16 round, we get that particular ciphertext over. Right. So here again we are doing this multiple DES. So multiple DES says that we basically have two types of DES here. That is double DES. That will be your double DES, and the another one will be your triple DES. That will be your triple DES. Like it is also known as 2DS and 3DS. Okay, so we will start one by one. So starting with this portion of double DES. So we can here see that we are having in 2DS, we use two different keys. We use two different keys here, and both the keys are of the size 56 plus 56 bits. Okay, so total we are having 112 bit key here. Okay, so we can say that in 2DS or double DS, we are using two different keys of the size 56 and 56 bits each, and we can just combine that both the size, and so that we can say that we have a total 112 bit key unit. Fine. Now we will start with this particular part, like that is the double DS portion here. Okay, so we will start with this particular part, that is a double encryption. Of course, like double encryption. So we use a formula over here, that is P equal to encryption. P is your plain text, encryption K1 and the P1. Okay. So encryption is what we can say that, like we are encrypting that particular plain text over here, and we have K1, that is the key 1 here, and next is the P, that is that we are applying this particular key on that particular plain text. Fine. Now, what we will be doing here again in this encryption part, we are having key, that is K2, comma E, and we will include this complete formula over here like this, E, A1 and B. Why so? Because we are saying that in double encryption part we have two DS over here. Okay, so we are using double DS over here. So for that double DS, in order to implement that double DS, we are using two different keys over here. So that's why you can see over here, we have first implemented that key 1 on that particular plain text. Again, we are encrypting that particular, whatever the ciphertext that we will be getting here by using the key 2. Right? Now, what will happen? Now, in the diagrammatically form, we can show like this, like we are having 64-bit plain text, and we will include that DES cipher. How we can implement this particular DES cipher? By using a key over here, that is T1. T1 and which is of size 56 bit. Okay, so this is the 64-bit plain text we are having, and next we are having that DES cipher over here, and we are having K1 56 bit over here. Fine. So K1 is your key. So then we have DS cipher over here. And what is the size of my key? That is 56. Fine. Next, we are having a 64-bit middle text here. We are having 64-bit middle text here, or we can say that it is acting as a temporary cipher. Okay, so or we can say that it is acting as a temporary cipher. Okay, again we will apply that DES cipher over here, like this DES cipher, and we will be using another key for that, that is K2, which is of size 56 bit. Okay, which is of size 56 bit. And finally we are getting a ciphertext over here. Okay, so this will be your final ciphertext. Okay, so this we can say that this is the encryption block diagram of your. So now this is the diagram for the encryption part that we are having over here. Okay, so we are having 64-bit plain text, and on this particular, so I just again repeat this particular part. So we are having that 64-bit plain text over here. So in that 64-bit plain text, what we will be doing, we will be applying that DES cipher algorithm here. Okay, so we are applying the DES cipher by using a key 1 over here, that is a 56-bit key 1. Okay, so after applying the first this DES concept, whatever the content that we will be having, that will act as a temporary cipher for us. That will act as a temporary cipher for us, and we are having 64-bit middle text. So what, because we haven't changed that particular format here. So finally, if you know that, if you remember the DES cipher algorithm over here, so we are having 64-bit middle text over here. Finally, again on this particular middle text, we will again apply the DES cipher algorithm, but using a different key over here, which is known as a K2, and again it will be size of 56. Okay, it will be again the size of 56, and finally we will be getting that cipher text. Okay, and finally we will be getting the cipher text. So this is how your double DS will work. Okay, so just remember one thing in this part, that this so just remember one thing, that like in double DS we have to use the concept of DS 2 times, but for every time we require a different key. Okay, so we have used K1 here, and again we will use K2. Clear? So again for the decryption part, so now this work as for the decryption part. So for the decryption, keys will be applied in the reverse order. Okay. First we decrypt using the key K2, and after that, which will produces the single encrypted ciphertext over here. And after that, again we will apply the key K1 on that middle text, or the middle, we can say that temporary cipher that we will be giving. Okay, so just remember one thing, in case of decryption, we will be applying the keys in the reverse order. So I just make that particular diagram for you. So that is the decryption part. Here you can see this is the decryption portion. And in this particular part, what we will do, we will first have the DES reverse cipher. So we will apply all those algorithm in the reverse part. Like here we are having K2. First of all, we will be having that cipher over here. That is the case of the decryption portion. So what we have in case of a decryption part, that we will have that cipher portion here. On this cipher part, we will first get the DS reverse cipher. Reverse cipher. Okay. So for that particular reverse cipher, we have to use key 2 first. That is a key 2 first we will be using here. And again, we can have that make it clear that everyone understand this way. So we are now focusing on that is double this DS part. So we are having double DS decryption. Okay. So here we are having cipher. On this cipher part, we will apply that DS reverse cipher. Okay, so how we can apply that reverse cipher using P2? Okay, so we are using that P2 over here, and here we will get 64-bit middle text. Okay, so we are getting that 64-bit middle text over here. Again, we will apply that DS reverse cipher by using the P1. And finally, we get the plain text. Okay, so this is as simple as it works in the encryption part, but just remember in the case of a decryption, we will work in the reverse order, and that particular reverse order, we have to apply the keys in the reverse order. So first T2 will be applied and then T1 will be applied. Clear? So this is regarding that double DS part. Now the next type of multiple DS is the triple DS. Okay, so next type of DS that we will study here. So again, you can just see the diagram. We have cipher. We will apply that DS reverse cipher here using T2, and we will get that 64-bit middle text here. And on that 64-bit middle text, we will again apply that DS reverse cipher by using the key. So in case of decryption, just remember one thing in case of double DS, that keys will be used in the reverse order. First T2 will be used and then T1. Okay, next type of multiple DS is triple DS. That is triple DS. Okay, so here what will happen? Two or three keys are used. Two or three keys are used. That is much stronger than double DS. This is much stronger than your double DS. Okay. Now here we will make both the diagrams in which we are using encryption using 2 keys and encryption using 3 keys. Okay. So we can start like this. Like we are having, so first part is encryption using 2 keys. And okay, so here we are having decryption using 2 keys. First, we will discuss the 2 keys concept, and after that, we will go to the 3 keys concept. Okay, so first of all, what we have a 64-bit plain text. On this plain text, we will apply that DES cipher using the key 1. Okay, so whatever the output, let's suppose we are getting the output A over here. Okay, so we are getting the output A over here. Now, what will happen? We will apply DES reverse cipher. Reverse cipher. So we will be getting that DES reverse cipher here by using K2. Okay, and again we will get some value over here like B, and on this B again we will apply that DES cipher. using the key 1. And finally, we will be getting that 64-bit cipher text. Clear? So you can see here what we are doing. This is encryption using the 2 keys. So first of all, we will be having DES cipher, 64-bit plain text is there. On this 64-bit plain text, we will apply the DES cipher using the key 1. Now let's suppose you are getting the answer as A over here. On this A, again I will apply the DES reverse cipher. DES reverse cipher, but with the help of a key 2. Okay, I will not be using the key 1 over here. I will be using key 2 over here. So I will get some different answer for that. That is B. Now on this B part, again I will apply the DES cipher, and we will be having that with the help of a key 1. And finally, I will be getting that 64-bit cipher text. Okay, so finally, I will be getting that 64-bit cipher text. Okay, so this is encryption using 2 keys. Now in the decryption part, you can see over here that how this decryption part will work. Like we will be having that 64-bit ciphertext. We will apply here DES reverse cipher. Reverse cipher. Okay. By using the key 1. Right? So we will be getting the answer in the as B. Over here, again we will apply DES cipher by using the key 2. By using the key 2. And again we will be getting the answer A. So that is DES reverse cipher. Okay, so we are getting DES reverse cipher over here by using the key. Okay, and finally we will be getting the 64-bit plain text. Okay, so finally we will be getting 64-bit plain text. Okay, so you can just see this works for the encryption part. Here we will just again repeat for you. This will work for the encryption part. Now we are doing DES encryption using 2 keys. Okay, so we have 64-bit plain text. We will convert it to DES cipher part using key 1. We will get some particular answer here, and on this particular answer we will again apply DES ciphertext, DES reverse cipher, and using that key 2, and we will get some particular answer over here, that is B, and again on this B part we will be getting that DES cipher. Okay, so we will again apply that DES cipher by using the key 1, so that finally we can get the answer 64-bit of cipher. Now, when we have to work according to this particular part in the decryption portion, so we will start from the reverse order. So we are having 64-bit ciphertext over here, and then we have DES reverse cipher. We will apply the DES reverse cipher on this ciphertext part using the key 1, and we will get some particular answer B. And again, we will apply the DES cipher using key 2. And again that reverse cipher. So here you can see that we have applied DES cipher 2 times and reverse cipher only single time. But in case of a decryption, we have applied reverse cipher 2 times and DES cipher only single time. Okay, so keys are, you can see that keys will work the same, but the order of doing that implementing DES is quite different. Okay, so this is all about that how we can perform encryption using 2 keys over here. Similarly, we have the another part here, that is encryption using 3 keys. So this is about encryption using 2 keys and decryption using 2 keys. Now we will discuss the part where we can apply that encryption and decryption using the 3 keys concept. So we are under the triple DES only, but we are here, we will be in this triple DES, we will be using 3 keys.
So sometimes in exam it may ask you that it is necessary that for triple DS we require 3 keys. So it is not necessary. You can use either two keys or 3 keys. Okay. So we can have triple DS using 3 keys. So that is encryption using 3 keys, and here we are having decryption using 3 keys. Okay. So we will start like this, that we are having 64-bit plain text, which is the requirement of this DS, as we have already discussed in detail while discussing the DS algorithm. So we are having 64-bit plain text over here. Here we will apply DES cipher. On that particular DS cipher, we will be using the key 1. Whatever the output that we will be getting here, on that particular output, we can apply DES, reverse cipher, and we can get that. But this will be applied using key 2. And again, we have to apply DES cipher, and here we can go for key. Finally, we will be getting 64-bit cipher text. Fine. So the processes will remain the same that we have already done in double DS, but the main difference is that at that time we were using only 2 keys. Here we are using 3 keys over there. So we are having key 1, key 2, key 3. Again, we will be having 2 DS cipher over here and 1 reverse cipher process. So this is the encryption part using 3 keys. Now we will go for the decryption part using the 3 keys. So here we will have to start from the bottom, that is 64-bit. Ciphertext will be available to us, and we can perform that DES reverse cipher. We are performing that DES reverse cipher using A3. Okay, so we get the answer B here and here. So first we will get this B, then we have DS cipher, and we will apply this DS cipher using key 2. We will get the answer in the form of A, and finally again we will apply that reverse cipher over here. DES reverse cipher, and we will get the answer using the key 1, that is 64-bit plain text that will be fine. So just remember one thing, in case of encryption, we have only 1 reverse cipher here and the 2 DS cipher that will be applied, and in the case of a decryption, we are using 2 reverse cipher and 1 DS cipher. So we will not go numerically so much in detail because it is quite lengthy part, as you have already seen in the simple DS only. So it required so many diagrams, so many implementations was here. But just for the reference, you can just remember that how you can use this triple DS and double DS concept. So this was all about that triple DS using 3 keys. Fine. So I can start with a new topic here. Okay, we will start with a new algorithm over here. That is the last algorithm of your first unit. So that is a blowfish algorithm. Okay, so this blowfish algorithm is somehow related with your the DS only. So we need to discuss that particular blowfish algorithm. So we can start with like this, like we are having blowfish algorithm.
And first of all, I will discuss some of the features of this Blowfish algorithm. Okay. So this particular Blowfish algorithm, it is also a symmetric encryption algorithm. Okay, so this is also symmetric encryption algorithm that says that we have to use same keys for encryption and the decryption. Fine. So this is how we can represent over there. That is Blowfish algorithm. Okay. So it is a symmetric encryption algorithm. Again, it is a block cipher algorithm. Block cipher. That is 64-bit algorithm. It is. Okay. It is an alternate to DES part. Like if you are not interested in implement DES, you can use this Blowfish algorithm because this is somehow more compact as compared to the DES part. So that you will able to understand when you will start implementing this particular algorithm. So this is an alternate to your DES encryption algorithm. So block size or plain text, we can say that in one block is 64-bit. Okay, so what is the size of your blocks that you will be using here? That is 64-bit. Okay, now the important thing here regarding this particular Blowfish is that is a key size. So here your key size is variable. So we, as you know that we have discussed so many algorithms so far, but in every case we have a fixed key size. Okay, but Blowfish is only the algorithm is there that can have the key size of variable size. Okay, so it has variable size. Variable size of key is present starting from 32-bit to 448 bits. So if you remember in case of DS also, so we have a fixed key size. But in case of a Blowfish, just remember this point, this is quite important point, that key size is of variable size and it can start from 32-bit to 448 bits. Okay, it can start from 32-bit to 448 bits over here. Okay, so we can also have number of subkeys, that is 18. Number of subkeys. This is the size of keys. This is the number of subkeys. So total we are having that 18 subkeys over here. And we represent them with the term P array. That means starting from P0 to P17. So all the keys will be there. Total how many keys we are having? 18 keys are there. We consider that keys in the form of an array. So we will start from the P0 to P7. And each and every this subkey is of 32 bit. Okay, so if we are using the 32-bit key over here, that size will be 32-bit for each and every array. Once you have allocated that particular size, it will remain same for all the subkeys. Okay, so total number of rounds will be 16 here. So Blowfish algorithm, like we are having total number of rounds will be 16, and the number of substitution boxes that we have already done in that. Yes, number of substitution boxes is 4 S boxes we are using. 4 substitution boxes we will be using. Okay. So that particular 4 substitution boxes will be having 256 entries. That will be having 256 entries. That is of each is 32. 32. Okay, so we will discuss in detail how these substitution boxes are used and so all those things. And finally, it follows crystal structure. It uses crystal structure. So where we have already implemented this crystal structure, that is in the case of DES.
So it uses crystal structure also. Okay. So these are some of the features of Blowfish algorithm. So you just remember all these points. That it is a symmetric encryption algorithm. That means we are using same key for encryption and decryption. We have a block cipher algorithm over here. So we'll be using that block, whatever the cipher algorithm that will make, that will be come out in the form of block size, and that is of 64-bit. This is an alternate method to DS. That if you are not interested in implementing DS, you can use this particular method of Blowfish. And the main prominent feature of this particular Blowfish is that we are having the key size that is of variable size. Okay, so the key size will be variable in case of a Blowfish part, and it will start from 32-bit to 48-bit. So any size you can use for that particular key. Okay, starting from this is the minimum size and this is a maximum size. So that is 32-bit to 448 bits. Next is that number of subkeys that you will be having here, that is 18, and we represent that particular number of subkeys as P array, that is starting from P0 to P7. Like if you are having 32-bit size, so it will remain same for each and every P array. Next is number of rounds are 16. Okay, that you understand that where we require this rounds with the case of a crystal structure. And number of substitution boxes are 4 over here, and it uses a crystal structure. Okay, so that substitution boxes are also having 256 entries, each of 32-bit. Okay, so one by one we will discuss each and everything here, that how all these things are implemented. So here you can see. Now, there are also some properties of this algorithm. Like it is quite fast. Okay, it is a fast algorithm as we compare to the DS part. Okay, it is a compact, so can require less memory space over here. It is a simple process because we are using only XOR and the add method, and it is secure because we are using variable length. Variable length. Just remember all these points in case if somebody asks you to distinguish between the DS part and the Blowfish. Okay, so it is quite fast. It is compact because its size is quite less. Simple because we are using only XOR and add function, and it is quite secure because we are having variable length. Fine. So after that, I will start with this particular part. So first of all, we will discuss that how we can generate subkeys over here. Okay. So first of all, we will discuss in the case of this Blowfish algorithm that how we can generate subkeys over here. So how many subkeys are there? Total how many subkeys are present that we have already discussed. That is total 8 subkeys are there. Okay. So the first thing that we will discuss here, generation of subkeys. Okay, so we can say that 18 subkeys are stored in P array with each array element being 32-bit entry. Okay, being 32-bit entry. So how we can represent all these elements, like we are having this P0, P1, P2, P3 till P70. Okay. So what we are saying over here that we will be having that particular keys over here, that is of, we can say that 32-bit. 32-bit over here. Okay. So here what we are doing, we are representing this 32-bit array in the form of hexadecimal. So we can write anything over here, 2, 4, 3, F, B, 6, A, 6, 8. Okay. So this is the first key. Again, we are having 8, 9, 7, 9, A, B, F, 3, so on.
So how many elements we are having? 1, 2, 3, 4, 5, 6, 7, 8. Each bit will be represented with 4 bits over here. So 4 into 8 will cause you the 32-bit. Okay. So we are representing this hexadecimal representation of each sub key. So in the case of hexadecimal, how many elements that we are having over here? That is total 8 element, and each element is representing with a 4-bit number. Okay, so this is how we can represent that particular sub keys over that, how we can generate this particular sub key. Okay, so we have a total, we are representing with a particular array part starting from 0 to 18, and each sub key will be having 32 bit size. Okay, so this is your P0, P1, P2, so on, 1, 2, 3, 4, 5, so on till so last will be 17. Okay, so because we require a total number of sub keys are 18, and we are representing it with a P array. So first of all, we will find all these elements. So this is any type of a key that you can, random key that you can mention using the hexadecimal code. Okay. Now what will happen? Now we have to each of the sub key is changed with respect to the input key. Okay, so whatever the key that you will be giving over here, that is P0, so we have to represent that particular key by the given key with itself. So how we can represent this particular part? So I just read. First of all, we just see that we are representing this key in the form of a hexadecimal format. So each key will be of 32. Okay, so next point is that we are now each of the sub key, each of the sub key is what? That we have started from that P array P0 is changed with respect to input key. So we will be giving some input key also. So how we can represent over here? That is P0. So this is a P0 that you have calculated previously. XOR, we will be applying that first 32 bits of input key. Input. Okay, so first 32 bit means P1. Again, P1. We have changed this particular keys. So we are having P1 XOR second 32 bit of input key. Input key. So we are representing K2. So total, how many keys we are having? So what is the maximum size of the key over here? That is 448. Okay. So what is the minimum size is 32 and maximum is 448. So how many keys we can generate from starting from this 32 to this 448? How many keys can be generated if we consider that each key is of 32 bit? So total we will be having that 14 keys over. So that is 14 into 32. What will be your answer? That is 440. 14 into 32 means that you will be having total highest size is the 448. So that means you can have 14 subkeys of 32 bit each. 14 subkeys of 32 bit each, that will represent your maximum size of 4. So here you can see that what we have done in the previous case, we have just represent our keys in the form of a hexadecimal form. Now we are changing that particular keys. How we are changing? Like the given P0 that we were having, and we are XORing with the another key. Here we are finding this P1, P2, that is from this particular size, that is 440. So any random size, any random number value you can take over here. But how many total keys will be there? That is a K14. So K1 will be there, K2 will be there, until it will work till K14. So it will go starting from the 0, it will come till the end P13. Okay, so till P13, all your keys will be get finished over there, because maximum keys that you can you can generate from this 448 bit is the 14. Now, what about like total size of this P array is 18. So we are left with P14, P15, P16, and last one is P7. Okay, then only it can be 18 sub keys will be there. Now we have ended the P14 last year with the P13. Now again, what will happen? We will use P1, P2, P3, and P. Okay, so we will repeat it again from the P1, P2, P3, and P4. Clear? So again, I just repeat this part. Like, firstly, remember that in the case of a generation of a sub keys, what happened that whatever the keys that we are using, that is in the hexadecimal format, that we have already mentioned previously. Now again, we are changing that particular key over here. In order to provide more security, we are changing that particular key. So what we have done, from the total size that is given to us, that is 448, we can develop 14 different keys of 32-bit size. So what we are doing, that P0 that was we have calculated previously, we will XOR it with the first key, first 32-bit key, that is P1, P2. Total how many keys we can have? 14 keys. So till P13, we can easily calculate all those values over here till P13. Now, what about P14, 15, 16, and 17? So we will again repeat that P1, P2, P3, and P4. Okay, so that is P1, P2, P3, and so this is how finally you will get the keys value. Okay, so in a simple way, I can just again represent the same thing. Like okay, so what total key size is 448. Maximum size is this. So I am again repeating, just listen it carefully. That is 448 bits. That means 14 portions we can have, or 14 subkeys we can have, that is of 32 bit each. 32 bit. Okay. So like we are having keys from P1, P2 to P. Right? Now, how we can change our key array over here? Key array like P0, P0, P1. P0 exclusive or P1. P1 will be having P1 exclusive or P2. P2, this is the new value of P0, 1, 2. So we are having P2 exclusive or P3. Okay, so it will work till P13 and we will be having P13 exclusive or P. Okay, so that will be a P14. Now we are finished with this part. So again we will repeat here P14, P14 exclusive or we will start with the first P1. P15, P15 exclusive or XOR and we can have P2. P16, that is P16 exclusive or P3. And finally we are having P17, that is P17 and finally we are having exclusive or P4. Okay, so this is how we can calculate our this particular, how we can generate our particular. Okay, so finally this is the bit. Clear? Now the next thing is that now whatever the values that we will be getting over here, we will represent it with the help of an array. P0, P1, P2, so on till P7.
So we will just locate their values over here like form of a PF. Okay, so this was the first step, like that is the generation of subkeys. So this was your first step over here. Now what is the second step? So second step, we will initialize the substitution boxes. We will initialize the substitution boxes here. So we will initialize the substitution boxes. Step 2 will be initialize substitution boxes. So earlier I already told you that we have four substitution boxes here. That is S0, S1, S2 and S3. Okay, that is used for decryption and encryption. Okay, so they will be having 256 entries. 256 entries of 32-bit each. Okay, they will be having 256 entries of 32-bit each. So this is a point that you must remember in case of this substitution boxes, that we will be having four substitution boxes over here. That is S0, S1 and S2 and S3. And finally, we will be having that 256 entries over there, that is 32-bit each. Clear? Now, the step 3 is that how we will not go in so much detail of the substitution boxes. Just remember that it will be having 256 entries of 32 bits. Okay. So here we will discuss the encryption process. Encryption process that will be done with the help of a crystal round. So this is a step 3 that I have to explain in detail. So I'm just repeating this particular point. So I'm on step 3. So step 2 was related to the substitution boxes. Step 3 is that encryption process. So in encryption process, as you know that, as I told you earlier also, that in Blowfish we are using 16 rounds and that rounds belongs to crystal bar. Okay, so here what we will start with, that we are having 64-bit plain text. We will divide this 64-bit plain text into two parts, that is L1 32-bit, R1 32. Okay, so L1 32-bit and R1 32. Now, what will happen on this L1 part? We will have that exclusive OR operation over here. This particular value L1 and one key, that is P1. So we have calculated that P1. We can get that value of that P1. So now see, I'm starting from P1. So in previously we have discussed from P0, but for your reference, for your easy way, I have used that P1. Okay, so P1, P2, P3, P4, and last element will be P18. If I start from P0, my last element will be P7. So I am, for your convenience, I am using only P1 so that you don't get confused. We will be having easily matching of both. Okay, so P1 will be there, that is 32-bit. You know that P array we have calculated that 32-bit. P1, this is your left bit, and what will happen over here? We will be excluding or both this value to this part, and whatever the output will be getting, we will be passed to this function, that is f. Now let's suppose this f will be having some value output, that is f li. Li is the left element. Okay, f li, that will be your left element over here, and again you will perform that exclusive OR with this right part. Okay, and finally, whatever the answer that you will be getting over here, that will be your L232. Okay, that will be L232 bit over here. Okay, L1 and L2, that is from the 30. Okay, Now, what about right part that you are having this L32 bit and P132 bit. After doing this exclusive of whatever the answer that you will get, it will move to R232. That will be R232. That will be your right. So this is your first round. This is your first round. First round. So I again repeated, just listen it carefully that how we can get all these values over here. So what will happen, first of all, we will be getting that 64-bit plain text over here. We are dividing that 64-bit plain text into two parts, that is L132-bit, R132. Okay, so what will happen, whatever the value of this L132-bit we are having and the P1 value that we are getting from that P area over here. Okay, P1 value 32-bit, we are performing an exclusive OR function and directly the answer can be become your R232. That will become your right part. But when you will get some values and you pass that values from that particular function f and whatever the FLI value you are having, again you are performing that by combining this FLI and this R32-bit value and you are performing that XOR operation on it and whatever the answer you will be getting, that will be your L232. Okay, so it will work similarly for all the rounds, but in case of it will work till L16. So till L16, everything will work same like this. That is L16 and R16. Now after that, there is a we can say that there are different steps that we have to follow. That in case of a L16, we are having exclusive OR with the P16 value. Okay, we are performing exclusive OR with the P16 value and we will pass that value to that particular function and again we will be performing that exclusive OR with R16. We are performing that exclusive OR with R16 part and finally we can get the value that is P7. Okay, so again we are getting that particular value over here and again we will be performing some changes over here. So R16 till R16 it is fine and for the 17 part what we are doing undo swapping over here. So whatever the swapping of the values that will take place, we will be performing all these values. We are having P16 and we are doing from passing it to some particular function and we will be getting again doing that exclusive OR over here and finally we are using this P17 here and again we will be performing P18. P18 is what? That is your subkey. So again we are performing that exclusive OR over here. And finally we will combine both the values in order to get 64-bit ciphertext. So somehow this question I think that will be clear to you. Again I will repeat all these points and again with the help of the algorithm steps that you will be able to understand. So first of all we are having 64-bit plain text. We have divided into two parts, L1 and R1. L1 plus your P1, that is the first subkey. You will perform exclusive OR function. Whatever the output that you will be getting, that will be your R32. But if you after whatever the output that you have get after doing all this calculation, when you will pass this particular output from this function, you will be getting some value in the form of FLI, and again you will be performing exclusive OR with R132. Okay, so after performing all this operation, you will be getting the final value that is L. So till P16, L16, it will work same. Now what about 16, 17 and the 18 part? So we are left with 16, 17 and 18 part. So for that particular 16 part, what will happen? We will perform exclusive OR with this P16, whatever the output of L16 we are having, and passing it to the function, we will give it to the R16 part. Okay, so that is the like we are having all this value of R16 and finally for that 17 and the 18 part, what we are doing, we are just undo swapping over both the values. Swapping means this value will come to this point and this value will come to this point, and finally we will combine both the values in order to get the 64-bit ciphertext over here. So I just write the steps of this algorithm so that you will be able to understand that how we have performed this part. Okay. So first step was that divide plain text to two blocks, that is L and R of equal sizes. Equal sizes. Second step is that for I equal to 1 to 16. Remember in that diagram 16 that all the rounds will work same. So 1 to 16, what do you have to do? Li will be equal to Li exclusive or the Pi. That value will remain the same. Then we have already done Li, Pi, and that will become your left part of it. And what about Ri? Right eye or Ri, we have F and Li. So if you have drawn that diagram along with me, so you have understood that where we have got this particular value of F Li plus R. Okay. And after that, what we have to do for that till 16, it will work same. Now for 17 and 18, what will happen? That like we are starting from 1 to 16, so total how many subkeys we are having? That is 17 and 18. Okay, so 17 and 18, what we'll do? We'll swap L1 and R1. Okay, so finally we will swap L1 and R1 over here. And third step, undo last swap. Undo last swap. After doing all those swapping, again we have to undo that last swap. Again we will move to their original position over here. And finally, in the fourth part, we are having R equal to R17, that is exclusive or with the P17, and left will be equal to left exclusive or P. Okay, these steps are the three different chain steps in your last part of the rounds. So here you are having that R equal to R exclusive or P17 and L equal to L exclusive or P. So I have already mentioned in that diagram. Okay, now the last part is that concatenate. Concatenate means combine L and R to get 64-bit ciphertext. To get that 64-bit ciphertext. Okay, so just remember this point that first we have to swap both L and R values. After that, again we are performing undo on that. So we have to re-swapping that particular part, and finally on that R part we are performing XOR operation with P17, and for L option we are performing this. Clear? So this is the main steps of your algorithm function. And finally, we are left with the last part here, that is the function part. So like we have used that F part in that encryption process. Now we will discuss that what we are having in that function part. So what we are having for that particular function box over here. So you can see that is function F. So how it will work? In that particular function box, we are having S boxes, substitution boxes. How many substitution boxes are there? It is 4. So S boxes are there. We are having 8 bits as input. Okay.
This is your 8 bits input. Total 32-bit input was given to that function. Remember that diagram? 32-bit input was given, and total we are having 4 S boxes, so 8 bits have been given to each box. Okay, so what we are doing over here, we are using one operation here, that is add, and we are adding both these values. That is 32-bit, 32. And whatever the answer that we will be getting, we will be using XOR over here. And again, we are XORing it with this particular S box here. That is third S box. So that is 32. Okay, next is add. And finally, again, we will perform that add operation. And finally, we will get that 32-bit. Sometimes, so this is what is happening under that function. So in that function box only we are having 4 S boxes. Each S box will be of 8 bits and total combination size will be 32 bit. If you remember the diagram, in that function input that we are giving, that is of 32 bit. Okay. So what we are doing over here, 32 bit is here, 32 bit is here. We are adding both the values and we are giving whatever the output we will get, we will perform exclusive OR with the third S box. And again, whatever the output that we will get, we will add that particular value with the fourth S box. And finally, we will be getting the answer as a particular. That is in the form of F, L, I. So value, this was the value that we were getting, F, L, I. So this is how what we are getting. Clear? So this was all about that function box in Blowfish algorithm. And obviously, we have completed this particular part of Blowfish algorithm. So I hope that you have understood this concept. So this was all about this Blowfish algorithm. So if you have any query, you can ask me later.